Hey Level 3s, and welcome back to 3.4 Atomic Structure and Bonding. This is Lesson 13 Part B on Hess's Law. Okay, so we're going to go through one last example and then we're going to do a task together, and then you're going to do some homework for me. Okay, so it says here, the question is calculate the enthalpy of formation for ammonia using the information below. So we always start by doing a desired equation. So formation is the energy released or absorbed when 1 mole of a substance is made from its constituent elements under standard conditions. So we're going to make, it's got N and H in it, so we have to do half N2 because that's how nitrogen exists, plus 1.5 H2, and we're trying to find out the enthalpy of formation. So hopefully that makes sense. They've given you 2 equations here. Okay. And so yeah, let's just get started. So there are 2 ways that you can do this problem, and it's up to you how you do it. I probably find it easier to manipulate straight away the whole thing. So if we look at equation 1, we obviously need ammonia, but we don't want 4. Okay, we only want 1, and we also want it as a product. So to equation 1, I'm going to divide by 4 and I'm going to reverse it, which means this needs to become positive, and we need to divide by 4. Okay, in the second equation, you need 1.5 H2. Okay, and so therefore I'm going to times this one by 1.5. Okay, yeah, and so that means that's going to be times by 1.5. So let's go through to the next slide. Okay, so you can see I've divided by 4. And you can see there are some weird fractions here, but it becomes easier as we start to do the cancelling out, and you'll see why I've written them like that. And then the second one was to times by 1.5, so 3/2 is 1.5, and so you'll see that it makes it easier when we go to do the next bit. So then we have to do the cancelling out. Okay, add them together. So we add all of the reactants together and all of the products together. Okay, and so we can start cancelling out. So I haven't actually done like a full adding together, but these are all the reactants and these are all the products. So we can kind of see it quite clearly. So 6/4 waters is the same as 3/2. So we can just cancel that out. So sometimes it's easier leaving it in those fractions. And then the next one we can cancel out is 3/4 O2, and then you'll see you're actually left with your desired equation. So 2/4 is a half N2. You make one of those, and this is another reactant, because remember these are the reactants, and you get 3/2 H2, which is 1.5. So we've got our desired equation, and then you can just add them up, and it becomes negative 47.5, which is 3 significant figures, which you have to do for E. So hopefully that made sense. This part here, don't get confused. I hadn't actually done this as adding all the reactants and products together. So the left-hand side here were reactants and these were the products. So just slightly different, but you guys should be able to get that. Okay, so that's actually, this is the second way of doing it, but we won't worry about that. Okay, final equation. This one's a little bit hard. So I'd love you to pause the computer and actually give this one a go on your own. And I'll start going through it now, and then you can listen to me once you've had a go at it. So here's our desired equation. This time it was given, okay? And so let's just get started. So quite easy to see that what we need from equation 1 is F2O3, but we don't need 3 of them. So we want to divide by 3 to this equation. So divide by 3. Okay, in the second equation here, what do we want from the second equation? Now, when there's equations, a bit of a hint where like we need CO, but CO appears in multiple equations. Ignore whatever comes up in multiple equations, because it usually sorts itself out. It's like the O2 situation. So we can see that we want 2 Fe, and Fe only appears in equation 2. So we know we have to times this one by 2, and we want Fe as a product, so we know that we're going to have to times this one by 2 and reverse it. Okay, so times by 2, and that becomes negative. Okay, and in the final equation, what do we want? Well, in this one here, this one's actually an interesting one. You actually need to think, because I said, remember, to ignore the things that appear in multiple equations. They sort themselves out. So equation 3 here, this is the first time you're having to do one like this, which is why I've said it's quite hard. We're needing to manipulate equation 3 because we need to cancel out F3O4 with this here. because we don't want this. And remember, this is going to get divided by 3. So this is going to be 2 over 3. Okay, so therefore we need to times this equation 3, by 2 over 3, so that we can cancel this reactant with this product so that it's not in our equation. So we need to times this one by 2 over 3. Okay, so let's go through and make these changes. Okay, so divide by 3 to the first one, okay, which I've done here. Oh, gosh. Which I've done here. Okay, times by 2 in reverse, and times by 2 over 3. So we said all this, and I've made these changes here. Again, I haven't added these together because they get really messy when you add them into one full equation on the screen. I can barely get them all together. So I've just done it like this, remembering everything on the left-hand side here are your reactants, and everything on the product side here, and we need to cancel out species that are common to each side. So let's just get going and see how easy that's going to be. So the easiest one is this 2 over 3 Fe3O4, that can go. Okay, you've got 2 FeO that can go. Okay, and is there anything else that can go? And actually there isn't. You've got 1 Fe2O3, which we want. Now let's look at this CO. So we've got on the reactant side 1/3 CO plus 2 CO plus 2/3 CO, which makes 3 COs, and then we've got no COs on the product. So that's perfect. So these all add together to give the amount we want. And then when we look on the product side, we've got 2 Fe, which we want, and then the final thing is 3 CO2s. And again, you've got the third CO plus 2/3 makes 1, and 2 makes 3, and we've got our desired equation. So now we just add up all of our values and give our answer to 3 sig figs. So if you manage to do that on your own, very well done. You've understood how to do this. These do take a lot of practice, so the whole rest of the lesson is you guys giving the worksheet a go, which is using past NCA exam questions. You're going to jump on Teams now with me, and we're going to do 2017 together. Then you're to do 2016 through to 2007 on your own, just those ones, because the other questions on the worksheet are using the second method for Hess's law, which we're doing next lesson. This one, you have to post this answer on your OneNote for me to mark. Hopefully that makes sense, and I'll see you soon, team.